Okay, so now we can look at the half angles. So remember from previous, we had cos 2 theta is equal to 1 minus 2 sine squared theta. So these we call double angles, right? So the key is we needed to remember we had basic identities. Then we went to sum and differences. Then we went to products to sum. Then we went to sum to product. Okay, then we went to double angles. And then now we're looking at half angles. Okay, the order could be a little bit different, but these are the main ones that we looked at. Right, so now what we're doing is that we're at double angles and we're trying to derive half angles. Okay, so now what we'll do is we'll say that let theta, for example, is equal to x over 2. Okay, so we're going to replace x over 2 everywhere. Okay, so here we're going to have cos 2 theta. Okay, remember we are trying to replace theta by x over 2 times x over 2, like that, is equal to 1 minus 2 sine squared. Then here we'll have x over 2. Okay, so this can cancel out, and then we'll have cos x is equal to 1 minus 2 sine squared x over 2, meaning that we can solve for sine x over 2. Sine x over 2 will give us something like this. If we take there to be negative, this is negative, so then 1 becomes positive, cos x becomes negative. Okay, cos x, and then we're going to divide by 2, but then we had square here, so meaning that we're going to have something like that. So meaning that now we can replace this with we can represent it as sine theta over 2 is equal to, because it's the same, 1 minus cos theta over 2. This gives us the half angle for sine. Okay, so now we can look at the other double angle. Okay, so half angle. Again, the key is to start from the double angles, so which is the previous step that we did. So here we have 2 cos squared theta minus 1. We're going to say the same thing. We're going to say let theta is equal to x over 2. Okay, so I'll put x. If I put x here, I'll get cos x is equal to, if I put x here, I'll have 2 cos squared x over 2 is equal to minus 1, right? Minus 1. So I can take this to the other side, it will be plus, that's cos x plus 1. Then here, we said we can divide with that 2, and then we can find the square root, because this is squared, to leave us with cos x over 2. This is the other half angle. Okay, so we can put theta there where there's x. Now we can say cos theta. Remember, it's not the same theta as this, it's just a representation. Then we can say plus or minus, because we are doing a square root of something. So minus 2 squared is equal to 4. 2 squared is equal to 4. So you see that why we're saying plus or minus. Then this will be cos x plus 1 over 2. That's our second half angle. Let's look at the third one. So we can move to tangent. So this one now, if we wanted to make it turn, we can say sine theta over 2, right, over cos theta over 2 is equal to this whole statement here, 1 minus cos theta over 2. Then we're going to divide with 1 plus cos theta over 2. And also we'll have square root. But then remember here we have plus minus, plus minus. We haven't forgotten about this. Okay, so what does this entail? This tells us that this is tan theta over 2, right? Then since it's the same angle, and then here now, okay, if you remember at if you remember radicals, so these are the same as square root of a over b. Okay, so it's the same. I'm dividing these two, so I can do big division thing. So I can do 1 minus cos theta over 2. Now, I'm dividing by this, so I can already skip that step and multiply this, okay? Because division will end at that. So let's just write it the way it should be, cos theta, right? The 2's are going to go. Here I still have my plus or minus. Then tan theta over 2 will therefore be plus or minus. Then we have 1 minus cos theta over 1 minus plus cos theta. Right, so this is the third half angle. So in summary, we can list the three half angles as follows. Yes, so these are the three half angles. So we have this one for sine, and then we have that one for cosine, and this one for tangent. So these are the half angles. So just to finish up, these are the main aspects of identities that we need to know. So the first one, we said that we have the basic, which included the tangent, the inverse, Pythagorean, and then we had the odd or even functions. Okay, then we went on to say, okay, beyond that, now we're going to look at the sum or difference. Okay, then we said that we can go on from these, so these can help us to develop this, and then these ones, they can help us to develop the product to sum, okay, and then we said that product to sum can help us to develop the sum to product, okay, sum to product, okay. Then the idea of sum to product can help us to in fact, not directly this, but we can say that we can move from the sum or difference to double angles. Okay, we can move to double angles. And then from double angles, we can move to number 6, which we said were half angles. Okay, so if one knows the basic, the difference and sum, product to sum, sum to product, double angles, and half angles, then I think that you are now ready to deal with any problem that you might be given in trigonometry. The only thing that you need to understand next is the reference angles, because this one now helps us with the domain when we are solving trigonometric equations. Okay, so next we'll look at the reference angles. In fact, next we'll look at some tricky maybe identities that involve all these aspects, and then once we finish with that, we're going to look at the reference angles and then be able to